Today I'd like to take up stacks, and the topic that we will do today is insertion in a linked stack, right? Insertion, that is your pushing, right? Now we have seen how to do an insertion in a stack which is in the form of an array. Now let's do it with a linked list kind of a thing, right, with pointers. Here basically it's something like a linked list, right? So see, first of all I'm going to make this like you used to have the start in the linked list. Now this is basically the top here, right? This will contain the address of the top of the stack, and these are the different nodes of your stack. I'll put it like this so that it looks like a stack, right? And in each and every node we have got a next pointer, right? Here like this. Fine. Now supposing this top, this has the address 3456, right? And now this is the node which has got the address 3456. This is the top of the stack. Here you have got some information. Let's say the number 5, right? And now this top is pointing to the next one. Let's say the address here is 4532, right? So here this one is your 4532, and here you have got the information, and here the address of the next node, right? Now this one, this is the next node. Let's say this is the last one, suppose. So 54, supposing I have the information 7 over here, and here this will contain none, right? So here the link has been made like this, right? From top it is coming to this place, from here it is coming to this, right? So basically when we want to push an item into the stack, when you want to do a push operation, in that case one node gets created, right? And that node is like this. Now whenever we do a pushing in the stack, the pushing is always from the top, right? So if I want to insert this node into this stack, then obviously the new node will be created like you used to do in linked list. The new node will get an address, right? Supposing I say the address is this for this node. Now when we do this, basically what we want is the link from top should come to this place, right? So what does that mean? That means this address which we have written here 3456, this address should get modified with the address of the new node, so that is 5543, right? And whatever was in top earlier in top it was 3456, right? Earlier top was equal to 3456. Now I have changed top to 5543. Now here the information part is there, suppose let's say 16. Now this node will have to point to this one, okay? So then only the link will be formed. So what does that mean? The earlier address that was there in top, it has to be saved in some pointer, and that address will now have to come here so that this link is made. So basically this link which we have made here, this link is not there now. This link I am breaking. Fine. So now we have inserted a new node. Earlier we had 3 nodes, now we have put 4 nodes here, right? And the address of the top will keep changing when you push an element into the stack, right? So now let's look at the algorithm for insertion in a linked stack. The first thing that you do is you have to take a pointer, new PTR, and you create a new node, right? Now this new PTR, this will have two things. One is your info part, this is your info part, and this is the next pointer or something like that, right? You can give any name you want. I put it as next. Now new PTR info, right, that is equal to item, and this is the new pointer that you're making, I mean the new node that you're making. So here whenever you make a new node, the next pointer of that will always be equal to null, right? So this is basically creation of the new node, right? Creation of the new node for the stack, right? Now after that, this new node has to be inserted. Always remember that when you are doing stacks, the insertion will be always at the top, right? Now we check if top is equal to null. If top is equal to null, what does it mean? It doesn't contain any address. That means the stack is empty, right? So if top is equal to null, that means this node that you have created, this node will be the first node, right? So top will become equal to new PTR. Understood? If top is not equal to null, that is we already have some nodes in the list, as the case we had taken up like this, right? Now in that case we come to the else part and we say new PTR is equal, new PTR link or next, here I have taken it as next, is equal to top. So whatever new node we created the new node 5543, right? That 5543 we had put in top. That is what we have written here, new PTR next is equal to top. Then top is equal to new PTR. Now look at this here. Like I'll put it here once again. Supposing this was top and this is the new node that you're creating. You already have a node here, let's say, right? So this is the node which you already have, and here let's say the address is 1290, and this is basically 1290, and here you have got some information, and here you have none. Now when I create a new node, this is the new node that we create. We have some information here. This is basically this part, new PTR info. So we put some information 34, let's say, and when you create the new node, this is also equal to null. Now I want to do the insertion. This top is not equal to null, so we will come to the else part. Now see what we are doing. This is new PTR, right? Okay. Now I'm saying new PTR next is equal to top. Now what is new PTR next? New PTR next is this place. When I say new PTR next is equal to top, this null is replaced with the address that is there in top. So this becomes 1290, right? Earlier the link was here, fine. Now I have made it as 1290 here, fine. And then I say top is equal to new PTR. So what is the new PTR? Let's say the address of new PTR here, the address let's say is 1009, right? Now when I say top is equal to new PTR, this becomes 1009. So now you see the links have been redefined. 1009 means it is pointing to this. Got it? and here the next pointer is 1290. So basically this is pointing to this node. So this link which was there earlier, this link is now broken. So this way we have inserted a new element, right? So this is basically the algorithm for insertion of an element in a linked stack. Basic thing here is this particular coding which is for the push, and the other things are almost similar what we did in the linked list. So I'll take up the program for this in the next session, and then we will do the algorithm for popping in a linked stack. So with that I come to the end of this session. Bye.